All right, so let's get started on shifting left. I know this is a buzzword, it keeps coming around, right? So, what essentially is this shift left, and how does GitLab enables shift left? So, this first session, we'll be talking, we'll see how to take advantage of GitLab in terms of enabling the shift left and catch our mistakes right at the merge request. Instead of months later when it's spotted by random security scan. We don't want to do that. And we will review the code that enables the security scans and create a merge request to bring it into the main, right? So that's now let's talk about a little bit on GitLab. So GitLab is a leading example of single DevSecOps platform. And that facilitates the shift left approach by empowering your teams to balance speed and security and also securing your end-to-end software supply chain, right? So at GitLab, security is embedded as part of the DevOps process itself. It's not a separate component. It is, as we call it, DevSecOps. So with all the capabilities inbuilt, GitLab can provide system-wide governance, visibility across your entire software development lifecycle of any vulnerabilities, securing this software supply chain, and most importantly, adhere to the compliance requirements, whether it's a regulatory environment or at the enterprise level, where you need to define custom policies to secure your CI/CD pipelines. Now, this is like you would say, why do I essentially need all of that, right? Why do I need so many capabilities? But what you see on this screen is now are the numbers from a research study done by NIST, the National Institute of Standard and Technology. And the thing it highlights is the impact of inadequate software testing, right? The annual cost to the economy of software errors, whether it's security or programming errors, is almost 60 billion, right? And for an average enterprise, that's essentially 300 software developer hours per year spent in remediating these errors, right? And that's a lot. And furthermore, the average cost of these data breaches industry-wide is close to $5 million. And the amount of data breaches you would be hearing across the news as well, it has increased to 72% since 2021. And wow, that's a lot. So now if you look at the right side of this slide, this graph represents the cost of remediation at each stage of development. This is a normalized graph, and it signifies that if a developer is able to identify and resolve the errors in the early stages, then the production, the cost of remediation could be significantly low. On the other hand, just imagine if the vulnerability are released to production. Not just the risk we are exposing our application to, but also the cost of remediation increases by a lot. Hence, the shift left, right? Hence, we would want to have security not just as a part of a separate component, but throughout our software development lifecycle. Another thing that I would want to highlight is in effort to count the impact of how GitLab's inbuilt security could make an impact, Forrester aggregated the interviews experiences and combined the result into a single composite organization, which is like an organization, hypothetical organization of with 5,000 initial users, growing at a rate of 25% year over year, and an annual revenue of 60 billion. Now that said, we as in GitLab was able to reclaim almost $5 million in the lost revenue, just based off of the efficiency of managing those issues early in the life cycle. Then we helped saved 9.4 million through reducing the time spent integrating and configuring security tooling by adoption of GitLab platform instead of the point solution. So I always talk about with my customers that, hey, when we think about solving a problem, do we want to do it strategically or tactically? Do I want a set of tools that can help me fix it, or I want a single platform that does it for me? And at the same time, I would question, okay, I don't want point solution. Maybe I build something homegrown, like something like a homegrown solution and manage that. this could eventually cost the companies, as we've seen across the industry, it could even cost like close to 44 millions, which you would use in order to manage, build your resources just to keep up with your homegrown applications, right? So all of this leading to saving like $48.3 million through greater efficiency in managing the vulnerabilities. And we can see the stakes are quite high, right? And the value of GitLab platform is very compelling. All right. So how do we achieve whatever I'm saying? Maybe I sound biased, but I'll tell you not. So we'll go through the exercises today and you would feel for yourself like how we would enable the DevSecOps platform throughout the SDLC. So GitLab does provide feedback on security finding immediately after your code is committed, right? So security, like I said, is built into your CI pipeline. And so you get that feedback immediately, right? And you're not waiting until the code is deployed into some testing environment or into production. So thereby you are enabling the developer efficiency. So making it much more faster and noticeable for your developers to act upon. Now, that said, how does GitLab enable security with end-to-end governance? So what you see on the screen, it provides you with a collection of metrics, ratings, and charts for vulnerability detected by the built-in security scanners, right? The security dashboard provides data such as vulnerability trends over like 30, 60, 90 days time frame, a letter grade rating for each project based on your vulnerability severity, the total number of vulnerabilities detected within the last 365 days, right? So if I am a manager or a senior leadership wants to have an oversight of, okay, what's happening? Give me the data points of these 365 days, including the severity. I want to see how can I improvise my security posture within the application? So I need to have one place where I could see all of this data. Now, again, coming back to tactical versus strategic, do I want to essentially confuse or make my leadership do some context switching, go to another tool set for dashboarding? No, I would want it at one place. I should be able to have an oversight at the one place. That's what GitLab does. And that's part of our workshop today. You would see how we can detect the vulnerabilities in the dashboard, how we can detect the security scanners within the dashboards and the results of it. So we would do that as well. And then the final piece, driving efficiency by enabling the visibility across value stream analytics, right? You can use these value stream analytics dashboard to identify trends, patterns, and opportunities for digital transformation. So the key is who does it first, right? And who does it securely? Who does it the best? Right? With all the visibility that you can get within the report, whether in terms of I want to see the life cycle metrics. I want to see the deployment frequency. What are the lead time for the changes? Time to restore the services. All of these details I wanted to have in one place to make it more convenient and visible across the different teams. All right. And then no conversation goes without AI, right? So we have, along with providing a single DevSecOps platform, GitLab enables teams a central place to discover AI-powered capabilities. Okay, when I say AI-powered, the first thing that comes to my mind, okay, just code suggestions. No, no, don't get yourself wrong. It's not just the code suggestions. We do the explanation. We take care of when I think about it, like as a different team members who are involved throughout the life cycle, let me wear the a hat that of a product manager. And I look at it, oh my God, like so many epic summaries and then the description I have to take care of. No, no. GitLab AI or our GitLab tool, AI tool called Duo takes care of that. So not just providing the code suggestions or code explanations, but also taking care from the planning phase itself. Give me the epic summary, give me the issue summary. Then, okay, let me wear the hat of an AppSec team member who is like, okay, I can define the vulnerabilities, but is my developer able to understand what this vulnerability is all about? So GitLab Duo helps you explain the vulnerabilities as well as automatically resolve it. So if you see throughout the pipeline, that's what we are doing with AI-powered SDLC lifecycle with GitLab Duo. I'm hoping like a lot of interesting questions are coming at the back end, and then you are getting answered too. But we'll also have a live Q&A sessions towards the end of the workshop today, so we'll take care of that as well. But all right, so let's get our hands on with the workshop. And the first one that you see is shifting left. All right, you all. So I hope everybody now has the account, has been logged into the workshop lab, is able to redeem the code, and also able to see my screen. Just one of my team members, can you confirm if you can see my screen on the hands-on labs?
We see it.
Perfect. All right, so let's get started. So the way I like to do it, like I have two windows open side by side. And once you start with the application, the first place you would see, you get into like a compliance workshop, and you would see a lot of details around code, sandbox, like some sample scripts, a lot of details. Well, at your leisure, feel free to read these, but then the place we would want to get started in interest of time is the issues here, right? So the GitLab issues, and then to begin with, first one, shifting left. So I have my instructions here on this page, and then I have another window side by side open where I will follow those instructions. All right. So please let me know, or one of my team members know if I'm going too fast. I'll just go slow. So let me know. So the first thing that we want to do is this issue provides the hands-on instruction for our workshop. To start, please assign yourself in the top right corner in the assignee section. It is suggested that you keep this issue open in a separate tab as we progress through the hands-on portion of the workshop. Again, just as a reminder, you would see, like often I would ask you to go back and forth through the breadcrumb. I'm using a different like a browser, so that's why you see my breadcrumb to be appearing like that. I have just a space problem here, right? So I'll go back and forth these breadcrumbs and navigate through the portal as well. But then you should see on your screen this sidebar where I can assign this issue number 1 to myself, right? Again, just be assured you should be inside the Tanuki Racing Security Compliance Workshop. You should see just one project like within your group called the Tanuki Racing Security and Compliance Workshop. As we get started, assign this issue, like the first issue. You get into the issues and you assign the first issue to yourself. Yeah, I can minimize these, but again, you can keep it open. Next step is, once ready, use the left-hand navigation menu to click through the build and pipeline editor. Here you will see the current setup of our main branch pipeline. Notice that there are 3 stages which are further defined below. So if I go here and I go to my build pipeline editor, which otherwise you would see in your repository as gitlab.yaml file. So I can directly go from build and then pipeline editor. And as the instructions say, we would see 3 stages. If for anybody that looks a little bit different, just let my team member know and they'll be able to help you on that. So if you look at this pipeline, it's essentially doing a very little in terms of security scanning. And it just has a simple unit test defines currently. We want to add security scanners to our pipeline, but no, if we were to just add them to the code base, any of the developer could comment them out in order to get their pipelines to pass. So prevent this, we are going to add certain pipeline execution policies and the project. So if you see, I'm just taking like the latest Docker image, the services defined for the Docker. I have variables, a few variables defined for like the driver, and then the Docker TLS certificate, the stages. It's pretty much bare minimum, right? So what I'm going to do next is, once I review my pipeline editor, I'll go to, again, build and then pipelines. Yeah, fair and square, simple. So we reviewed our pipeline editor in build, and then we went back again within build, the second option as pipelines. And now we're going to run a new pipeline. So make sure that you are on the main branch. Nothing to be done here, just leave it as is and run this new pipeline. So if you see, I have multiple stages, which is like the build, test, release. I could even see the jobs that are running. Like currently it's running at the build stage. And I have no essentially like tests, like a test defined, but that has not started yet. So simply waiting, let's wait for that. And while this is running, let's do another thing. What I want to do, so again, this Tanuki Racing Security Compliance Workshop is my application where I have my application code. Now, what I want to do is I want to define a scanner pipeline, right? Where I do all the scanning or where I define the scanning policy there, right? So what I'm going to do, again, at the breadcrumb, sorry, my window is like this. Yeah. While this is running, and it's going to take a few minutes, go back to the breadcrumb at the top level where you see my test group, click on that. And I want to define a new project. So let's take a blank project. And I want to name it as, yeah, just be, in line with the instructions of how we are naming it. There'll be places where we have not defined any instruction, like name it in a specific manner. So feel free to name it as you like. But this one, it says that you create a project with a specific name, which is Tanuki Racing Scanner Pipeline. Yep. And keep all the settings as is, nothing to change, and then create the project. So if I go back to my test group, okay, I would see two things. One, where my application code exists. Two is the scanner pipeline that I'm going to execute, right? So again, I stepped back and showed you like two projects that will be created. One is the application, and I would often refer to as the application project so that you don't get confused, which is the Tanuki Racing Security and Compliance Workshop. That's my application project. And then the scanner pipeline project. So now at this time, I would get inside the scanner pipeline project and start configuring a pipeline or a YAML file. So let's go to the GitLab pipeline editor inside build, configure the pipeline. Now I'll explain the code one by one, but just get rid of what is there right now. And be sure if you're typing it out, I usually like to paste it so that I don't miss out on the indentation, at least during the workshop. Otherwise, you watch me while I'm coding. So yeah, just on this side, I'm going to paste as is. Looking at the instruction, let's go through what this code is essentially doing. Again, you're defining a latest Docker image. I want to make sure my trace logs to be like at the debug as true. I want to exclude certain secret detection paths, such as like courses or the golden demo paths. I have included two stages. One is build and then test. Now, at the same time, a lot of lines here, right? Inside include, I have included a couple of templates. These are our security scanning templates. And this is all inbuilt or pre-built within GitLab itself. So you just have to define it like as a one-liner that, hey, include the template for security, container scanning, or code quality, or dependency scanning, etc. Right? We have the secret detection, SAST, etc. And if I want to see, like, let me expand this. Okay. Right. If I want to see a full configuration, this is how, like just by adding those templates, one-liners, it'll add a lot of things around what's scanning, what are we scanning, what are we excluding, what are we taking care in terms of the code quality, etc. So this gives you the entire full configuration here. And that's done. And then again, going back to edit, let's commit the changes. I hope I did not miss any step, because if you do, again, it won't run as we would want it or expect it to run. So let's commit the changes. let me go back and show what's happening with the pipeline. So if you see this pipeline is still running, again, click on this unique ID and you would be able to see multiple stages. We're going to the code quality, container scanning. So IAC kick scanning, and again, this will be talked about as we go through the slide deck. We're covering a lot of these capabilities in terms of scanning. So if I click on one of these, or yeah, I think you would see a lot of logs that goes behind here, right? And a lot of things are happening at the back end. It's taking care of your code quality. I think the secret detection has already run. So let's go by that. This job has been successful. There is a whole lot of logs that go behind and you can view them here. All right. So now let me again go back to the breadcrumb and take a step back. So we have these two projects. We just define the YAML file within the Tanuki Racing scanner pipeline. The pipeline is still running. Now, what I want to do is from here, click back into the Tanuki Racing Security Compliance Workshop project. I'm at step 2. I hope you're following. If I'm a little bit fast, please let me know. But now going to the step 2 is where we click back to our Tanuki Racing and Compliance Workshop. We have our scanner pipeline defined. We want to ensure that it runs every time whenever there is any change within the compliance workshop, right? So on the left-hand navigation, we want to define a policy, right? Anytime if there is any changes, it should definitely make sure that the security or the scanning pipeline runs. So what I'm going to do is under secure, go to policies and create a new policy here. Then we would want to select a new policy. And once you select the policy, you would select multiple options here. Again, merge request approval policy, scan execution, pipeline execution, and vulnerability management policy. All of this, what each one of it does, will be covered in the session today. So need not to worry. But for now, just select the pipeline execution policy. Right? And now it does not have, like I said, it does not have any instruction to how to name it. So we can just name it as is and so I will call it as execution policy, pretty much it. And keep it like the policy status to be enabled. The policy scope applies to the current project. Then we want to make sure that this specific like inject actions is selected to inject into the GitLab YAML with the following pipeline execution from the projects. Like when you select the project, we just defined our secure pipeline, right? A scanner pipeline. Now I want to be sure, and let me just confirm how you would see like multiple options here. How you would want to be sure is you would see this unique ID here, like IUV, this part. I wish I could highlight, but yeah. So let me look for mine. Just remember, you would see the group name or the group ID in that specific URL. So select your scanner pipeline within your group. Like just be sure about doing that. And let me figure this out from my, like if you can see my, I hope you can see my URL and I'm able to select just the group ID here. And I could just put it in the scanner. There you go. This scanner pipeline I'm going to select, right? So this looks good. Then the file path, the YAML file that you define within your scanner file. So just add the gitlab.ci file. And we want to keep the things as is, no changes, the default branch, and that's it. So update the merge request. All right, so while this is happening, I just want to make sure that all my pipelines were run perfectly before. So going back to one more thing I would want to showcase here. So if you see, like initially, we just had these two, like this project existed already, which has my code, application code. Then we created the scanner pipeline as a new blank project. How did this come? So this is basically a project that creates while we ran the scanner pipeline, and it takes care of that enforcing all the compliance or all the security policies that we want to have every time a pipeline is triggered within the application project, right? I hope that's clear and there are no questions.
Nikita, you just want to make sure you hit the merge on that merge
Yeah.
request.
So that I want to do that. And then if I go to my merge request, sorry. Oh, which project am I at?
Yes, that's the one.
Yeah. So I went back, I looked at the projects, then make sure that you select the security policy project and then go to my merge requests, update the scan policies, and click on merge. Thanks for the reminder. So what will happen now? Well, this will take a few minutes and I hope I did not miss any step, right, James? So I go back to my
Correct. You just go back to your main
to
point.
the workshop and look at the pipelines. All right, so that ran perfectly. This is just a warning and ignore it for now. Nothing to worry about. It should be okay.
It will only run when you run the main pipeline for the main branch. So you can actually just continue to step 5.
Yep. So essentially now going back to so let's go ahead and create a new branch. And again, making sure you are at the Tanuki Racing Security Workshop. Create a new branch. You could just go to code and branches and then click a new branch. Again, name it in the way it is defined, like secure pipeline, and create the branch. Yep. So now while all of this is happening, again, there are times while we onboard new users or new GitLab users, do I want to really go back and forth in asking question and looking into the documentation? However, there is another way GitLab helps you in that. If you look at the top right corner, there's something called as GitLab Duo Chat, right? And while our pipelines are running and it's taking time to scan the results, etc., that's happening, I asked the question before, which existed, but I can just clear it up. And feel free, I think you should also see it in your UI, this GitLab Duo Chat. So click on that and just ask something like, ask a question like, hey, I don't want to look into my documentation. Just help me understand the GitLab security features, and it would provide you all of those details. Like instead of going back and forth with the documentation, you can simply, even throughout the workshop, if you have any questions that you might as well ask our GitLab team members, just feel free to ask with GitLab Duo Chat and it'll give you the right direction. So when I ask this question, GitLab provides a detailed answer of, hey, it offers a comprehensive set of security features to help you secure some applications, development processes, all the application security. There are certain key security features such as container scanning, continuous vulnerabilities, and everything. You know what? Often when we talk about, you could even ask how to make a pizza. Like not just limited to GitLab information, but you can ask questions with GitLab Duo Chat, which are like outside as well. So there you go. It gives you a detailed answer of while this question isn't related to GitLab, but how can you provide the basic recipe of making pizza and it gives you all the details? All right, so now that's done. Moving on to creating the merge request, right? So now we want to test that our policy is working and our scan a repository. So we will open a merge request. Use the left-hand navigation menu to click code and merge request. So again, just be sure you are inside the compliance workshop and click on code, merge requests, click on the new merge request. This is the tricky part. Make sure that for the source branch, you have secure pipeline. And yep, just type it up and you would see. So if you see my pipeline is still running, and then you could even compare the branches, make sure the target branch is your main branch, and click on compare branches and continue, right? So next step on this resulting page, make sure that you uncheck the mark as draft at the top of the page. Scroll down to the merge options, which is here, and I want to uncheck the delete source branch when merge request is accepted. So I'll just uncheck that. So basically, I'm just making a merge request, and following that, this merge request is essentially going to track my work. So once I create this merge request, I just open the edit code, and now you will know, like, we have the web IDE embedded into GitLab. So let's open the web IDE into GitLab. I think you might not see it because it pops up another window.
See it.
Okay, do you see it now?
Yes, we do.
Perfect. All right, so all we want to do is inside this code, once you have the web IDE open, I want to go into the lib folder, the library folder, inside the Tanuki Racing, and then go to app.rb. All I'm doing is just making a small change, like instead at the line number 45. So if I go back to the line 45, you would see here, just update the title to secure Tanuki Racing Home. Yep, so that's pretty much it. And you would see that there is once you have made the change, you would see this update, one pending change in the source control. You would want to commit to our merge request branch, which is like the secured pipeline, right? So click on, just add a message, update title, and commit and push to the secure branch, secure pipeline. So if you see like multiple things are happening here, right? Scanner pipeline at work, right? So if I go to my MR, okay, let me close this because I have it opened. If you see here, a couple of things are happening. It is ready to merge. Now this will take a few minutes. Let me open the pipeline and see what all is happening. You see, initially, I just had like 2 stages, and that's pretty much it. Like we did not have so much description with container scanning, or we didn't have the dependency scanning. How is all this coming? Just by including those templates within our file, right? It got triggered from the secure scanner pipeline, the scanner pipeline that we created. So think of the workflow. We made certain changes in the application code that made it kick that scanner pipeline, which essentially had to run all the scanning templates that we included, such as secret detection, such as SAS scanning, dependency scanning, container scanning, etc. And this will take a few minutes, and we are essentially at the end of our first issue, right? We can just go back to the MR and we did the MR, and then you should see the pipeline kickoff. If you click the hyperlink, it will take you to the pipeline view. We already did that, like the hash number that it generates. And it takes you where we see all the various jobs that we added through our main pipeline and the scan execution policy. Compare these stages and jobs to the one that ran in step one. So in step one, it was essentially just what we saw is, I think, the build and the test. That's pretty much it. And that comes to the end of our first issue. This is going to take a few minutes. So let's take like maybe a 5 minutes break and give you some time to catch up with the speed in case anybody is lagging behind. So we're at 12:50 now. Let's be back by 12:55, or let's take a bio break, have some water, and be back by then. All right, I hope everybody is back. And I saw a question, I think from I saw a question from one of the participants about how we navigated to the web IDE. So now there are two places you can, one, you can go into your merge requests and basically just select that merge request, click on code and open in web IDE. That's one place. Yeah. Or you could also go to the repository. And again, once you go to the repository, remember to do it for uh, the Tanuki Racing Security and Compliance Workshop, that project. So when you go there, click, you can even go to the repository and then look at edit and then click on Web IDE. So that'll open up the project in the Web IDE. So GitLab does comes up with the integrated Web IDE for your ease of use. Now, going back just to look how your pipeline should look like so far, and let me go to my pipeline here, and we see that everything has run successfully. You would see a green tick. It's such a relief to see all these green ticks, honestly. So you would see that, and that is a good segue to keep back our hats down of hands-on lab, and let's go back into the workshop, like just me talking through the slides, and you can just listen in. All right, all right. So let me just make sure that I am on the right one before I move back to the slides. Perfect. And okay. All right, so now back at my slide deck and starting the slide show again. So the next we'll go through parsing these scan results. Okay, what happens once I'm done with the scanning? I've done added certain policy. I want to see the results. I want to take action on it. How can I do that, right? So the next part of our workshop is parsing those results, and let's take a deeper look into the scans and the results of the scan, as well as create any policies we may need to prevent any security breaches in the future. So that's with that. And I want to start with an overview of GitLab security capabilities, right? There is a lot built into the platform. Just this morning, I was talking to one of the customers that they were creating like custom templates or writing code to just to reinvent the wheel, which already exists within GitLab. So I'd highly recommend that you use these pre-built scanning capabilities, which is right out of the box within GitLab. And across the entire platform, GitLab has the capability to manage the vulnerabilities in the vulnerability dashboard. You would see that, like we'll just do it in a minute. So we'll have something called as those vulnerability dashboards to give you an overview, to triage, to track, to resolve those vulnerabilities, giving you a full visibility to your organization's risk, right? Uh, Essentially, it is important to understand, okay, how can I improve? Where were they detected most of the time? So all of that, you can view that and triage that within the vulnerability dashboard. Next up is the dependency management, right? So track the dependencies used in your project. What happens is like the dependency management, the goal is to help the developers and the security professionals to understand exactly what third-party software organizations, suppose you're using certain open source tools or certain other libraries, and you want to make sure if there are any dependencies in that, and you want to track those dependencies. Um, okay. Sorry for that. Then we have the security license and approvals, wherein if you require an approval from the security team when a merge request has newly created vulnerabilities or licenses, use this license approval policies to specify criteria that determines when approval is required before a merge request can be merged. Now, and then again, scan enforcement, something similar to scan enforcement we just did requires the scans to run as part of your pipeline or on a specific schedule. So you would see that in one of the labs that we do today. Now, GitLab also offers the pre-built scanning, right? Where through features like static application security testing, secret detection, dependency scanning, infrastructure as code scanning, right? where you can analyze your code for vulnerabilities before a build even starts, right? Allowing you to identify security issues early in the development lifecycle. Remember the cost remediation that we are focusing on. We want to remediate, we want to identify and resolve it as soon as possible or as early as possible within the software development lifecycle. So we saw one of the scanning templates we saw that we included were secret detection, and it checks for your credentials and secrets in the code commits, and project history to proactively resolve prior improper disclosures. So this would monitor your activities to help prevent your secrets from being leaked, and to help you respond if like how to respond if it is eventually leaked, like how would you do that? Now, there are multiple secret detection methods, such as GitLab offers secret push protection, pipeline secret detection, and the client side secret detection. So, all of these are as part of the GitLab capabilities. Then we have the static application security scanning, otherwise like often called as the SAST scanning, where you scan your application code and binaries to check for weaknesses and vulnerabilities. And with GitLab platform, SAST results are also processed, so you can use them in all your approval workflows. One thing that I would want to highlight is that we recently introduced GitLab Advanced SAST, which is designed to discover vulnerabilities by performing any cross-function or cross-file taint analysis. So that was, I think, recently GA'd. So you can leverage that as well. So now, again, on the IAC scanning, I know a lot of people use Terraform or tools like that, OpenTofu for infrastructure as code. So you can scan your infrastructure files to check for secure practices, that checking your infrastructure definition files for known vulnerabilities, identifying vulnerabilities before they're committed to the default branch. Then again, the dependency scanning and the license scanning that I talked a little bit about. Moving on to the post-build scanning, right? So we have the container scanning, which essentially analyzes your container images in the CI/CD pipeline for security vulnerabilities. This is the most important part that I want to highlight is the DAST scanning. What it does is it analyzes your running web application for the known runtime vulnerabilities, leveraging the review app, right? So it would do an automated penetration test to find vulnerabilities in your web applications. And it would, also automate things like hacker approach that and try to simulate in the real world attack, such as things like uh, cross-site scripting or SQL injection, right? What you could even do with DAST, like you can run it in a CI/CD pipeline, you can schedule it as well or run it manually. So either schedule or run it manually within your web applications as well. Then fuzz testing, where you input unexpected and malformed data into your application to measure the response and stability to find unknown vulnerabilities, as well as the API security, where you analyze your APIs for both known and unknown runtime vulnerabilities. All right, so now this is the important piece as well. Along with those vulnerability, the scanners, templates, the scanning capabilities that is provided, GitHub also provide the security policies, how you can enforce those security policies to be able to enforce the control globally within your organization. So think of a scenario where your security team wants to ensure that the scanners are enforced in the development team pipelines with proper configuration. Take care of that. That all the scan jobs are executed without any changes or alterations. I want to enforce a policy for that. Or your security team wants that you enforce a central, like you enforce a policy that certain approvals or certain members are required to approve a merge request. So all of that is where you define the policy. I think a small, one of the policies we just did with scan execution policy. And essentially, to maximize the policy coverage, what we do is we link a specific security project, a policy project, to the highest organization unit that achieves your objectives, such as for the group, subgroup level. So if you saw, like, the security policy project that we did in the workshop, we had it separate out. It's just more for, you want to provide a granular access to somebody and you want to define certain policies, you want to enforce those policies. So we created at the like maximum policy coverage level, maybe in terms of like at the group level, the subgroup, or the project level. And anytime if a policy violation is detected, it will show up in your merge request. So anyone at a glance can look and see what's the history of this merge request and what did we find as we made our development changes. So if somebody like bypasses it, or if some violation has been detected, it'll just show up as the history within your merge request. All right, so this is in addition to, like I said, in addition to all these policies themselves, GitLab provides the ability to manage these policies as part of your compliance framework, right? So you can define granular user roles and permissions. You can limit access with two-factor authentication and expiration code. You can define like merge request approvals, such as defining how many approvals a merge request must have before it can be merged, or who can approve it. So all of these, or even if I want to have a protected branch, so all of these definitions or policy rules or definitions you can define as well uh, within the policies. So that's pretty much it. So now that is the good time that we head into our second lab, and which is about parsing the results. So I hope everybody is up to speed. And if you have any questions, if you're lagging behind, please just let us know. Our team should be able to help you on that. Okay. Okay. Let's go back to our merge request. All right. Cool things coming up. So as the instruction prep, this issue provide, like we are on the second issue again, and on my right hand side, I'm into the application project, like the Tanuki Raising Security and Compliance Workshop project. You would see it in the middle at the test group level. So we want to make sure, please click assign yourself in the top right corner again. Okay, so let me assign it to myself. It is suggested that you keep this issue open and the tab as we progress through the hands-on portion of this lab. Use the left-hand navigation menu to click back to the merge request. So I'm already there. I'm within the code, like the tab called code, within the merge request. And then click the merge request we created earlier. So we created this secure pipeline merge request, click that. Now you would see a couple of things are happening, right? We can see that the code quality, license, and security scanning, like right after this pipeline number, we see, okay, 5 license compliance issues were detected. Again, this comes as part of the third party tools or any dependency that you're using. So any licenses that were detected as part of those packages. Then you would see code quality, and we see like 21 new findings. Again, just to recap, all of this is coming as part of your merge request. So no more context switching, no more difficulty for my developer to go back and forth across the screens. Just have to be, and even for the product owner or somebody from the leadership, they want to have an oversight or have a glance of what's happening with each merge request. All of these details provide what code quality scan issues were found, or if there were any security scanning detected. It says like 61 here. This is bound to happen. We're part of the workshop, so we wanted to highlight these as well. And if I click on any one of these, like SAST detected like 25 new potential vulnerabilities. Oh, good news, like no secret detection detected, no new potential vulnerabilities. And then there were certain dependency scanning vulnerabilities, etc. So what I do, like, as I talked about, trying to understand as a developer, I want to understand and know more what is happening, where is it happening. So if I click on any one of these vulnerabilities, it'll give me a good description about this needs like a status, like it needs to be triage, or has it been taken care of already? What is the severity level? Is it critical, high, medium? Where is it occurring? Like within the project called Tanuki Racing Security and Compliance Workshop? What tool did we use? This result is as part of the SAS scan. The scanner we use is the KICS, which is also like the IAC scanner for that, right? So another thing, which at what specific file position, which file is it happening and what's the location? So it even gives you the breakdown of the line number and where the file has been located, right? Identifier. And this essentially just opens up like an Amazon doc or a public website to give you more details about what's happening. So that's pretty much it. We went ahead looking at the steps. We went a drop down. We went into the drop down in security section, scanning section, and selected critical high vulnerabilities. From this view, we can exactly know where it occurred in the code, read up on why it's a risk. And after taking a look, we can decide, is it relevant in the bottom? Yeah, I mean, if I click on it, I could just dismiss or maybe create a new issues altogether to find like put a fix for this one. So that can be done as well. Now we want to scroll down and merge our code. So let me merge our code here. And again, just be sure that if you have not unchecked like mark as draft, this merge request will start with draft. So you don't want to do that. Just like if I go to edit and there, make sure that this is unchecked, right? It should not be in the draft stage. So, okay. And this triggered the pipeline. Again, so a lot of these things are happening. And again, it is going to take a few more, like a few minutes here while this is running. Meanwhile, I wanted to showcase, like we would have to wait and you can see it in your merge request and the like the GitLab environment as well. But let me show you what essentially would show up after this entire pipeline is complete. So within this left-hand side panel, you would see like a security dashboard, right? Inside secured, you would see a security dashboard. So it gives us a lot of details as it was there in one of my slide deck, like, hey, what are the 30, 60, 90 days vulnerabilities that were detected? What are the severity levels of those? Which projects, like for now, I just have one project. So you would see like a one project as well, right? So which project was it detected? What's the status of it, right? Another thing that you would notice is the vulnerability report. Now, this is a whole lot of details, and this is the critical point to understand. This vulnerability report will give you all the details around 78 vulnerabilities that were critical were detected, 970 were high, and all that breakdown of the number of vulnerabilities that were detected. Now, let me select, we have the option to filter the different type of vulnerabilities that were detected. So I'm going to select like tool and then secret detection, and then just come out of it. And we can see, hey, there were two secret detection vulnerability that were detected, right? And then let me show you one more thing. So often, like if I select SAS and come out of it, and project. So what I could do, like I can see there are multiple SAS securities that were detected, and I want to look at, okay, let's pick up any one of it. Now, for me as a developer, this is like a lot of details I might not understand, right? What is this? Why is this like S3 bucket without server-side encryption? What does it mean? That's where like I talked about initially, the end-to-end AI empowered SDLC lifecycle. For me as a developer, I can simply click on explain this with AI. So that triggers a vulnerability explanation for me as a developer and gives me what is the cause, what's the exploitation example that's happening, why is it happening, what's the remediation example. So it just says that, okay, the attack, this is an example of an exploitation that can be caused as part of this vulnerability. They can take advantage of this vulnerability by gaining unauthorized access through your to your S3 bucket. What is the remediation example for it? So here is an example of source code that you can make changes. Do not do it now. We are in the part of, but again, it can be an exercise as you can do it later. Look at the remediation example and see if you can fix it within your application code, right? So going back to the instance and checking, okay, let me just rerun. Okay, we're almost there. So we went through the vulnerability reports. We saw like SAST, one under the tool, we filter out the vulnerabilities which were detected as part of the SAST scan. We saw explain or resolve with AI, and we were able to explain the vulnerability in simple language, simple terms, with explain with AI in GitLab Duo. Next, I want to do is like create a preventive security policy. So while I think we might want to like just give it a minute or two, I just want to wait till this completes so that we can get the accurate results as we want. So just like a minute's break, we can like 1 minute break we can have so that this completes running. And give you time to for you to catch up and explore the vulnerability dashboard and the security dashboard within your tool. So there you go. So we had a successful run. This is not at the moment required. Like it should be fine if it runs whenever it completed. That should be okay. But this is the essential part where we wanted to have their pipeline to be complete. Next, we just saw within the vulnerability dashboard that certain AWS token leakage was detected, right? So we want to make sure we create a policy that it does not happen in the future. So what we're going to do is just be sure, again, you are at the security compliance workshop project, right? We go to defining within the secure of this project, the secure tab, go to policies. We already defined the enforce pipeline policy. Now we're going to define a policy so that it detects if there were any token that was leaked by mistake or something, or those secrets that were leaked as part of the code commit. So what we're going to do is create a new policy and then create a merge request approval policy. Let's do that first. And I want to do is, this is like a scan policy that I want to create that does a daily secrets detection. And I want that to run this scan at 7 a.m. daily, right? And then when we would want to change a couple of things within the rules, right? When select the scan type, so we want to select the scan type to be like a security scan. And from all scanners, we would want to select clear all scanners and secret detection. So again, we are defining a rule here where we are saying when any security scan happens, then within that, enable the secret detection, not just for the protected branches, but for the default branches with no exceptions. And yeah, I think that's pretty much it. Like, and finds the vulnerability that matches all the following criteria. We keep this as is. One more thing that essentially we would, as we are creating the merge request approval policy, we would want to define somebody as an approval. So I have one of my team members, so we can choose that individual user as an approver who could approve the merge request. And in my case, I'm just going to select Logan. He's there on the call. So if anything goes wrong, he can help us. So requirement approval from individual user Logan Stucker. We define that. And one more thing to keep in mind, the uncheck this prevent pushing and force pushing, right? So when this is enabled, it prevents the pushing and force pushing to a protected branch if that branch is included in the security policy. So we just want to uncheck that for now. Then keeping it as is, you can also see we have something called as a fallback behavior and edge case setting. So suppose when the policy criteria cannot be met, do I want to make it like allow the merge request to proceed even if all the criteria is not met? Or I want to block the merge request until all the criteria are met. So right now we are just going to keep it as is. We're not going to change that. Please ensure you do the step or you'll be blocked later in the workshop. So just be sure. And then if I see this is coming down, otherwise it will be like on the left hand side. You could even see it in the YAML preview. So this is, we are defining the rule mode, and we can also preview the YAML mode as well at the top. And yeah, that's pretty much it. And configure with the merge request. On resulting merge request, click the merge and you will be brought to your new policy project that is applied to our workshop application. If you were to create another merge request with the leaked token, still in the code-based merging would be prevented until it was removed or added your approval. So let's click on merge here. Okay. And while this has been done, let's move on to the, again, lastly, use the breadcrumb at the top of the screen to click into your group and once again, click into your project. So going back to our group and then clicking back to the project here. Now, let's do one thing. Another step is about, let's introduce forcefully, let's introduce like an AWS token within our code, right? Let's try that and see if this policy is essentially working and is able to detect that. So again, on the left-hand navigation, just remember to be at the security compliance workshop project. And then under secure, go to the policies. So this time, again, we are going to create a new scan execution policy to find out if there was, by mistake during the code commit, if there were any secrets to be detected. So let's create a new policy and then create a scan execution policy and call it introduce. We can just call it anything. So introduce secret detection in code change. And one more thing that I want to do is yeah, keeping it as is. In the actions, under the actions, we want to define run a secret detection. Then we want to scroll down to the conditions and change the trigger to a schedule, as like I want to run it as part of my daily scan that happens at 7 a.m. And I want to make it for the triggers to the schedules, change the specific protected branch to a default branch. Then I want to do it daily at 7 a.m. in the morning and my time zone. So it's UT, yeah. So here you see the YAML code for that as well. So I'm just introducing a secret, like this is the policy, anytime a secret secret has been detected, this policy should run. So configure the merge request. Lastly, click on configure the merge request on the resulting merge request, click merge, and you will be brought to a new policy project that is applied to a workshop application. Now this scan will run daily and alert us if a secret was accidentally approved into our default branch. So let me just merge this for now. And again, while this is getting done, let's try to forcefully invoke a secret into the code base. So let's go back to my security group. I'll just take a pause. I hope everybody is up to speed where I'm going. But just to recap of what I just did is we defined a scan execution policy. And again, this scan execution policy is going to detect it. We defined a rule where if any secret is detected, it should run a scan every day, daily at 7 a.m. to detect if any secret was leaked or by mistake approved while the code was committed. So we just defined one of those policies. Now, the next step is where we get into the compliance workshop. And again, let's try and edit and add a AWS token or any, secret. So let me also include this window. I hope everybody was able to get into the web IDE. You just go to your repository for the Tanuki application security, Tanuki security and compliance project workshop. Just get into the application, go to the code repo, and then click on edit that you see on the top right, and then click on web IDE. So edit using web IDE. Yeah. And then what I want to do is, let's get in. This is one of the sample scripts here. And I want to introduce a small, like a secret within my description. So I'm no longer calling it as a specific variable or a field where I say, hey, this is like AWS underscore key or AWS underscore token. I'm not doing that. I'm simply doing it as part of just the description here. So let me just add this sample token. No, to not think it could help anybody, it's just a sample token here, but let's include that. Okay. So as part of this description on line number 6, I've included using AWS key ID and then this token ID, right? The token key ID. So I did that, and I can see in the source control, there was this change detected, like change detected, nothing as per the security as yet. Then we would want to create a new branch and commit. Just press enter. So you'll be, when you click on this orange bar and then create new branch, just keep this, press enter and keep it empty for now. And you would want to create the MR here. Like if once on the success, this changes has been submitted, create an MR. Okay, a lot of windows open. So let me close that. We have made the changes here and it creates an MR. So a new branch or a commit resulting on the drop down creates a new branch and commit to open a new branch. Then press enter. A new pop-up will appear where we want to create MR. We've done that. Once you do that, click on the create MR in the web IDE. You'll be taken back to the gitlab.com page. And all you want to do is keep it as is and uncheck delete. But before I do that, I want to show you one more thing. A lot is happening, right? We did the change, we came back, we created the merge request. Do you see this small summarized code changes? So long back, the history is like I used to be a developer and I used to hate writing these descriptions because it just like give me anything at that time I'm talking about, give me anything which is like non-coding or creating documentation and I will like, oh no. So that's where GitLab Duo comes into picture and you can create a summarized code changes. So if I click on this, ta-da, the description is created for me. And it's not just this, it's a lot beyond that. You can create the inline documentation for your entire application. That can be done as well with GitLab Duo. So for now, the workshop purposes, we're just going to create the merge request and make sure to uncheck the delete source branch, like right at the bottom. And we are blocked here, right? Because the approval, which I define as login, he needs to approve it. So you would see once the pipeline is done, you can see that our merge request approval policy has been enacted, restricting us from committing this code. If we did not add a secret token directly to our source code, we would be able to merge our code. but we won't be able to merge our code. You can come back to this merge request to review the blocked merge after the next section. So give it some time, because again, it's going to do its thing. It's going to scan the code and see if the secrets has been leaked. So let it run. And now is the time while it take, let's take like 2 minutes, or like, I think we're good with, how are we doing with the time, Jonathan? Are we good? Do we want to take a 5 minutes break and come back and start the next part of the session, which is about talking about S bombs, license approvals, and all of these details?
Yes, let's do that. We'll come back at 1:35 Eastern time. That works.
Perfect.
All right. Just wanted to quickly introduce myself. My name is James Nika. So I'm a fellow colleague and solution consultant here at GitLab, who will be taking you through the next two laps here at Tanuki Racing. We're going to be looking at a few more security-related capabilities that come with GitLab. I hope at this point everybody has at least caught up to where my colleague Nikita left off. I'll be switching back over to the slides to talk a little bit about license compliance and software bills of material, and uh, talk a little bit about that. So if you're following along, we have gone through an initial lab setup. At this point, we've done two labs, one on shifting left. Nikita also just took us through parsing those results, where we talked a little bit about merge request policies, pipeline policies, and you saw how you can actually go through the GitLab solution to actually set a lot of those up. Next up, I want to talk a little bit about these software bills of material. What are they? How do you manage license compliance within GitLab, and why is that important? Once that's over, I will actually move on to the next step, which will be really talking about on-demand scans. Why would you want them? How do you deal with audit type events? What is GitLab actually capturing about the different things that you're doing within the platform? And once we hit those two milestones, we'll really have reached the end of the workshop. We will then at that point, we'll be able to talk a little bit about how do I take all this work that I have done and followed through on and actually transfer it over to my own projects or groups within my own GitLab environment. Now, I am not going to actually do the transfer, but I will point you to where that information is. And then we can spend a little bit of time walking through some Q&A if you have any, and then close out the workshop. So in this lab, we're really thinking about the different types of hacks and challenges that we're seeing at a very, very high level. And especially if you're dealing with government customers, this notion of a bill of materials, very similar to, if you're familiar with the logistics or shipping industry, where you have a bill of lading, where you describe what you've put into your container. Very much the same thing applies in software. What exactly is my software composed of? Now, as an engineer here at Tanuki Racing, one of the things we kind of say is we need to make sure that we have these reports ready to go. And if we're using the GitLab platform, that information would be available so that we can pass that along in the event of a breach or anything like that. So where did all of this come from? I mean, if you think about the long list of security breaches that we have seen over the last few years, Fun City, Las Vegas was shut down for a number of days because of hackers taking over that infrastructure. I think I remember something about them having actually encrypted certain stores, and therefore people couldn't access the information, or you couldn't get key cards to actually work at the hotels. Um, you had the massive SolarWinds breach, Log4j, a very, very popular library. All of these led to the current administration requiring that for any companies that are going to be working with the government, they do have to deliver to, or have the ability to deliver to those federal agencies, what is known as a software bill of materials or an SBOM. And this is from the end of 2021 onwards. Okay. Now, I did want to very quickly, I had bookmarked a couple of things. I just kind of wanted to talk a little bit about this notion of the supply chain. So a supply chain in which you'd have a software bill of materials is really a set of components, all the libraries, the tools, the processes that are used to build software, right? So that's what the supply chain is. And within that supply chain is a whole host of material, all these things that are passing through. So the software bill of materials is nothing but an inventory of those components that are used to build all of that. And it may be some open source components, it might be proprietary software components, but all of them come together to give you the software applications that you know today. And again, this is all coming from that manufacturing heritage where there is this notion of a bill of materials that is used to manage part of a supply chain. Okay, so that's where the term comes from. All right. GitLab does offer and provide a mechanism to provide an SBOM report. Um, it is generated as you do these different scans using our security capabilities. And GitLab can also ingest a software bill of materials report within its system and save it within its database. There are a number of different formats in which these SBOMs are described. They are typically in the JSON format. So, I think JavaScript standard object notation format. Cyclone DX is just one of those formats, right? So whenever you see Cyclone DX, you should just think, oh, this is just a description of all the different components that make up my software, right? And it is designed deliberately in this sort of very common format so that it can be taken and consumed by other tools and capabilities that need to build out other kinds of reports about the security posture of your organization. Now, CycloneDX happens to have been developed by an organization called OWASP, a well-known entity within the software ecosystem that develops a lot of standards around different tools, different interaction formats. SPDX is just another format, also JSON-based, and support for that will be coming soon to GitLab. I will be showing you a little bit of those formats when we get into the lab, just so that you can kind of see what do these things look like, where can I read and learn more about them. All that will be made available. So with respect to SBOMs, we can think about how they're dealt with or the different things you can do with them in sort of four big categories. So generating the software bill of materials is probably the most immediate one you can think of. So when you perform a GitLab dependency scan over your code in a pipeline, this actually is when we generate a Cyclone DX formatted software bill of materials, right? For all your source code dependencies. And this doesn't really matter what type of language you're programming in, we will generate one. Container scanning will also generate an SBOM for operating system level type dependencies, right? And you can also use other third-party generators to be able to produce an SBOM. Again, with respect to generation of these bill of materials for software, SPDX, another format, will be supported shortly. I also mentioned GitLab can consume them. So we can consume a Cyclone DX formatted SBOM, and we will be adding support for consuming SPDX SBOMs as well. Now, these SBOMs, as they're generated, dependencies need to be continually, analyzed, for different things, for licenses, for versioning, changes that might be happening there, which also means that there might be changes in the vulnerabilities that are contained within them or resolution to those vulnerabilities, right? So this is something that the platform will also do for you. So here at Tanuki Racing, it's a fantastic thing that we're using, the GitLab platform. We're able to have this kind of continuous analysis taking place every time we perform that scan. And then finally, how do you actually merge the results, right, between different runs, right? And how do you merge the results of vulnerabilities together with what licenses are there? All of this needs to be kind of brought together and unified. So that is something that we do, as well as give you a mechanism to distribute or export it out, say in CSV format or in different formats, so that you can push those out. And we will be adding support for downloading that combined Cyclone DX and SPDX file format in the coming weeks and months. So at this point, we should be ready to jump in and perform one more lap through the workshop. We're going to jump back over into the instructions. This time we're looking at issue number 3. Your issue list should not quite look like this because you've been closing issue 1 and issue 2. So hopefully you just see issue 3 and 4 remaining, which will bring us home. Okay, so I'm going to switch over at this point and open up my view. So just like Nikita, we both use the Arc browser. If any of you are wondering what is this tool that we use, it's called the Arc browser, ARC. Very nice, allows me to sort of place two things side by side. I can have on my left side here my instructions as I follow them, and on the right side you can actually see the work being done. So I have closed my prior to issues as I work through them with the rest of the group, and I will now be opening that third issue. So, let me know if you don't see this or you're not able to have the same page, but you should essentially be in your Tanuki Racing Security and Compliance Workshop project on and at the same time have access to the instructions for that issue. So as with all of these issues, first thing you want to do is assign the issue to yourself so that you can also close it later. You can do that with this little arrow on the top left side and assign yourself to that issue. And then I'm going to sort of click that and close that out. And so the first step is we're going to take a look, review an SBOM report. So first thing I'm going to do is kind of show you where you can access this. So if you go into your left-hand menu and you navigate to the secure area and you go to dependency list, I do want to point one more thing out. Whenever you come to a menu within GitLab, there is a little pin icon that shows up on the right side. If you find that you are accessing a particular menu item quite often, you may want to just pin it. What that allows you to do is have a list of pinned items at the top, right? These are probably your favorites, if you can think of them that way, the items that you are going to be accessing the most, right? So in this case, I'm going to go over to my secure. I'm going to go to my dependency list, click that, and wow, there's a lot of material here. So you can see this is a software bill of materials, and it'll let you know when did it last run, right? So latest successful scan. I had run this myself. I'd run this a while earlier. So you can see that there's an export button there where you can export this as JSON. Look at the detail that we're kind of looking at here, right? So we have, you can go component by component. These are probably your libraries. Here's Git, which is packaged using the APT packager. This is just a tool that brings together this library. And you can see license information as well as the number of known vulnerabilities. And this is exactly what that government or auditor persona might want to see, is to understand what types of tools and capabilities are you bringing in? What are the various vulnerabilities that come with them? And I think Nikita was able to show you all a little bit about what do you actually see whenever you look at one of these vulnerabilities, right? And she kind of went through a lot of that and kind of gave you a mechanism by which you can actually get that vulnerability explained. But how do we actually export these in the Cyclone DX format? For that, you need to go to a slightly different place. So here we're going to actually go back to the menu, go to Build, and under Pipelines. And here I'm looking at my list of pipelines that have run successfully or not, but through the lifetime of my particular project. Okay. And in the actions area, in fact, if I just expand it this way, you probably see it horizontally, right, you will have an ability to see artifacts that can be downloaded. I'm going to look back a little earlier at some of the to an earlier pipeline. Sorry. And one of the things you can see there is there's a container scanning uh, Cyclone DX artifacts. So these are all the types of artifacts, including those SBOMs that have been built up as those pipelines ran. So here you can see a container scanning Cyclone DX option. You can click on that and that will pull it down. That's for your container scans. If you want to see the scans that are related to your actual libraries and not just the operating system components, you can use the Gymnasium dependency scan Cyclone DX file format. So you'll see other file formats appearing over time here. Now, I did mention I would kind of just go over and point a little bit about, what exactly are these Cyclone DX formats. So there is a website, cyclonedx.org, where you can get a lot more information about the types of things that are in there. And, it's a lot of very, very good information, the kind of information that from an auditing perspective, you probably want to get and take a look at. I mentioned you can get it in JSON format. And really what it's kind of saying is, here's the format that you're using. Of course, each format has a specific version number. And then for each of them would be the description of that library. Along with that are the ability to capture known vulnerability information that would come with that particular package. I also wanted to touch on SPDX, which is just another format. Again, pretty rich in information. This is a sample that is out there. You can download and look at some of these from the SPDX website. And it talks about the licenses. It can talk about, the different annotations, whole bunch of information about files that have been analyzed, the licenses that are included, who the suppliers are, and a whole bunch of other details related to those files. Okay, so that is the SPDX format. It's again lightweight format that you can also consume and open source. So that was the example that you kind of saw there. And now I just want to go back to continue with this. Now, there's a nice little note there that mentions, see how you could have used GitLab to detect the log4j vulnerability. So that's actually something you could take a look at. There's a link in there, and when you click on that, it kind of talks about, if you had just set up a dependency scan, one of the things that would have showed up, and this is how you'd have set it up, you just have included a template that we have out of the box within GitLab. You would have been able to detect a whole bunch of dependency vulnerabilities, including that log4j vulnerability. So this is quite interesting, very nice read. Please take some time to actually go take a look at it when you get a chance. All right. Continuing, license compliance. So let's talk a little bit about seeing some of the licenses that have been detected in our projects. You had seen the prior listing of the dependencies. Some of them were unknown. There were some GPL licenses. But now I want to actually kind of look a little bit more at, how we can have a policy that will control what licenses can be for, what types of libraries with what licenses are allowed within our solutions. So let's first take a look at that again. So we'll go back to that secure menu. I'm going to pull out the dependency list. And you can see here in the severity, I can select the packager. And here you can see different packages. And you can see based on whatever those licenses are, there's quite a few things that we do not know, right? And this goes on for pages. I'm just going to jump over further down, there's a whole bunch of libraries with a lot of vulnerabilities and a lot of different packages that go with that. So let's say we want to prevent the lesser GNU public license, one of many open source licenses that are out there, from being, any library with that license should, kind of be prevented and denied from being used. So let's see how we can do that. So we'd go over to the left side menu, navigate down to secure, and we want to create a new policy. Okay. So of these policies, I'm going to say on the top right, I want to create a new policy. And that policy is going to be a merge request approval policy, right? So this is the kind of policy we're going to be creating here. Now, my colleague, Nikita, worked with you through a lot of other policies like this, but what you were using was the rule mode, right? So this is a user-friendly click-through mechanism for creating these. I'm going to actually go a different direction, and I'm going to actually use the YAML mode. This is where probably I would say for a power user, you may want to just paste the resulting actual, declarative statements that make the whole rule and the policy directly in there, right? Because that's what we have on the left side. So I've changed over from rule mode to YAML mode, and then I'm going to just go hover over my actual policy here, and there's on the top right, there's a copy to clipboard icon. Click that once, and then I can come here, put my cursor within there, select everything with the, if you're on a Mac, Command A or Control A, delete it all, and paste this policy in there, right? So I've just copied everything in here and copied it over into my policy. Taking a quick look at it, right? Like, what is it really saying? Well, it has a name, deny the LGPL3 license, and a short description. It's enabled, which means it's an active rule. And the rule is really find a license. And if you match, you want to find that if you find a match for this string, which is LGPL 3.0, whether it's newly detected or was previously detected on a protected branch, right? So that might be like your main branch, then you should require an approval from one user. That user is specified using a user ID. In this case, this is most likely going to be Logan. And some of those same rules that you saw Nikita mentioning, which had to do with the preventing push and forcing, all of those things are also set. So once I'm done with that, I'm going to configure that with a new merge request. And once I get here, I'm going to hit merge. All right. Now, once I'm done with that, sorry, just want to come back here. Notice before I change back to go to my security and compliance workshop project, this clicking on that create with a merge request actually takes it out and puts it in the security policy project. This is why I have to actually go back to my original project to continue, right? So that's where that policy is going to reside. So now I go back to my root group and following through. So I just remembered to go back to my project using the breadcrumb. And now we have, now when we run a new pipeline for a merge request, a new approval rule based on this license compliance policy we just configured will be added to prevent any LGPL 3 items from kind of going through. We're not going to do it immediately. What we will do is we will do it in the next section. All right. So for now, we have reached the end of this particular lab piece. We want to close this issue, and we'll go back to the slides for a little bit. So if you just scroll down to the bottom, you can see the close issue, and you can hit that, and the issue is closed. All right. Let me give people 2 minutes to actually just catch up in case you are still following up before I kind of walk through the last portion here. In the meantime, if in these 2 minutes, if there's any questions, I'll take a quick look at the chat.
Yeah, James, there's one that's pending on the SBOM identification in a multi-language repo. Do you want to take that, or we can answer it on the QA function?
So what exactly is the question? Remind me.
So for SBOM identification in a multi-language repo, one, do you identify SBOMs from all languages? And two, do you look for the SBOM manifest files at all folder levels?
I believe at the moment, if it finds an SBOM manifest file, it does consume it separately. This is an item that actually I would love to confirm and then perhaps put an answer back, or maybe
I can
Oh,
answer
right.
this one.
Yeah.
So for multi-language repos, such as like a mono repo, it does pick up the different ones. So long story short, yes, it does identify SBOMs from multiple languages, and it does actually just like combine it into one output for said repo. I will link the docs for the supported languages in the question.
Thank you so much, Luca.
Yep.
All right. Just keeping things moving here. Going to continue with the last piece. This is the last lap here at Tanuki Racing. We're going to go one more lap, talk a little bit about on-demand scans, audit events, and the like. So at this last stage, I really want to look at, okay, we've secured this application. We're really happy with, a Tanuki Racing app that has all this compliance, all these policies in place. We got all this scanning going on. Uh, so you want to check, right? You want to be careful, especially for worst case scenarios. So we're going to just cover the tools that GitLab provides to support sort of those situations. Now, if you set your mind up and think about the state of that software supply chain that I kind of talked about, right? There's been a massive spike, right? Over 600%, year over year increase in whether it's dependency confusion, squatting, code injection. There are all kinds of things that tend to happen, right? And we're seeing big increases in, year over year in some of these vulnerabilities being spotted by developers. And this software supply chain requires governance. So, we need to know about these vulnerabilities. We need these dependency lists. We need some kind of compliance dashboard or management point that we can look at. There's a whole bunch of things from the governance and security perspective that we carry out. And these things have to target the different sort of pieces, whether it's just source code. We want to now begin doing things like applying AI to explain those vulnerabilities. You saw a little bit of that from Nikita. I believe right now GA is some of the actually vulnerability resolution, right? Remediation capability using an AI tool, Duo, will actually go in, suggest, and make changes to code to actually remediate those vulnerabilities. Again, your mileage varies. It depends on what it is looking at, but I've seen and actually worked with this capability to see it resolve some of those. Things like the ability to review and approve rules, approval rules that are in there, different kinds of scanning, secret detection. All of these things are source code related. From a dependency perspective, we kind of want to look at things like the composition analysis. What is my application composed of from a dependency point of view? We saw the license compliance piece, the generation of the SBOM. Now we're going to be adding capabilities such as the merging and ingestion of those SBOMs, group dependency lists, as well as a continuous scanning regime. From a build perspective, we've already got isolated build environments that you can build using the pipelines and the evidence of releases actually going to those environments. But now we're going to start doing things like automatically signing these releases, right? And you can get attestations and signed builds today. And then finally, from a release perspective, um, secure CI/CD tunnels, right? That pipeline needs to be secure so that you cannot have those malicious actors interject and insert unexpected components within the pipeline, whether it's through malicious containers, whatever it might be. API security, this dynamic application security testing, and being able to actually scan running applications, right? So it's one thing to scan and get vulnerabilities on static code and libraries. It's a whole other thing to kind of detect broken paths within running applications. So dynamic application security testing, which is really testing running applications on demand, is a capability that you can get today. So the way we do it is you can configure on-demand scans and run them as applications are deployed, whether in production or whether in staging type environments. And the support for especially browser-based applications is there. This proprietary scanner is used to use a browser to execute native JavaScript against the apps. And this is particularly useful for what are called single-page applications. So, these modern web applications that are all within a single browser page, and it's just the components within there that continually get refreshed, right? So the benefits here are really that coverage, right? All the different capability areas and vulnerabilities that could be there can be now covered much more fully. The other thing that we do is provide you with security education right within the application, right? So GitLab has partnered with organizations like Contra, Secure Flag, Secure Code Warrior, and within the application, you can actually see and have context sensitive training, security education being offered, right? For a specific vulnerability, right? So if you have a vulnerability within a report and you wanted to have that developer kind of understand what exactly is this thing and how can you actually resolve it, what are the risks, that is something that you can do there. Now, some of these do require subscription, so I don't have a way to actually show you those in action, but I will point out where they are within the settings. Audit management, we all know we're going to have a need to explain who's doing what within the application, and that's what the audit events are for. Like who's doing what, who's sort of violating approval rules, how do I stream these to my observability or monitoring platforms? How do I generate audit reports? How do I generate compliance reports, right? So these are all capabilities, again, that you will see within GitLab. So let's jump in to that final lab, that last stage, and I'm going to kind of walk through a little bit of some of the things I just talked about. All right. So it's going to change over. So I've closed my last issue, and you should only have one more issue available for you to in the open state that you're going to kind of work with. And like the good attendees that we are, we're going to first assign the issue to ourselves, right? So go up to the top right or go into the menu and select the issue and assign it to yourself. So now you are the person who owns that issue. All right, so that is my step 0. That's the prep where I assign the item to myself. The first thing we're going to do is set up an on-demand scan. We're not going to execute it, but we will save that scan and save the profile. So to do this, we're going to start by going to the secure menu on the top left. come down here and I'm looking for, hold on. Oh. I thought I had my on-demand scans area. Logan, why would I not have that?
Sorry, I'm double muted. Let me see.
Yeah, I think so. You're looking at the top group level. So
Yes, that's my problem. I should go into my project. See, we all make mistakes. So going in there, I'm going to see, oh, there you go, on-demand scan. So my mistake there was to be at the group level where I cannot perform or set up on-demand scans for a group, but actually have to set up for the project. So we're in there, we're going to set up a new scan. And in the scan configuration, I'm going to provide a name for this. So I'm going to say, just call this, issue 4 on demand just scan. So this is a part of my workshop setup. So these on-demand scans are going to be of the dynamic application security testing type, right? Then in the DAST configuration, I want to select the scanner profile and say I want a new scanner profile. So I'm going to go down here all the way. I'm going to say select scanner profile, new scanner profile. So what this is doing is kind of beginning to define configuration about the nature of this scan. Do I want an active scan, a passive scan? Things like the timeouts, how long should it try things for before it kind of stops, right? So here, I'm just going to give it a name and just say default profile. I'm going to leave it as passive, which just means, we're just monitoring requests sent to the targets to look for any vulnerabilities, right? Active, here, this could be potentially harmful. So, you have to kind of understand what you're doing with that. And that's really all I want to kind of set up there. You can also turn on debugging if you want a little bit richer of an output, right? So there's my default profile. The second thing is, well, what do I want to scan? Where am I targeting, right? So that's going to be a site profile. So I'm going to say I want a new site profile. Home application. I'm just going to call it that. This case is going to be a website, or you could hit an API. Just going to leave it at that. We're going to hit the amazing site that I have, which is example.com/home. Nothing else. If you had any exclusions, you could add those in there. Any additional request headers that you might want to add as well would be there. If you have authentication, you can click that and you can provide all the gory detail that helps you actually authenticate into the ad application. In this case, I'm just going to save that and leave that there. So that's really what you would fill out as part of a DAST on-demand scan profile. You would be providing information about how you want to go against it and what is that target site that you're going to be targeting. I'm not going to save and run that. I'm just going to save the scan. That allows me to actually later on come back. I can execute that. I can delete it. I can change its dynamics. But that's the way you would add a number of these. All right, let's move on to another aspect of all of this that we kind of had talked about, which is audit events. So you're going to want to know who's doing what when within GitLab. So if you scroll down on your left side menu to secure audit events, here you can see lots of details about all the things that I've been doing, right? So it's quite extensive. I'm going to go into one of these so that we can just kind of see. You can change the time ranges that you're looking at. You can see who the author is, who's the particular person to blame. This is my own project, so I'm kind of seeing a lot of those details. So here you can actually see, for a particular session, what were the changes that I did to that one. Sorry, just back. So in this particular, this is the target object, sorry. This is the particular action I performed. I added a DAS profile. I may have changed target branches. So all of this detail is something that you'd be able to export out, particularly with things like the IP addresses. If someone was changing policies, if someone was disabling approvals, these are the kinds of things that you'd be able to capture, and kind of like the Git blame feature, you'd be able to know who was actually responsible, and you can follow up on that. Okay. Extra scanner configuration. Let's go through that. So on the left menu, we want to go to the security configuration, right? So with this menu, there's a lot of different types of scanners that you can configure and you can turn on. Notice some of them are in an enabled state. So this is because we kind of went through and added all of these into our pipelines. So, Nikita added container scanning, she added dependency scanning, all of these things. I haven't turned on this, but if I wanted to, I can go through the same merge request process to be able to actually go in there and add that in. So still, within this security configuration area, we can go to this other tab, vulnerability management, and this is where you can see some of those elements that I kind of talked about with respect to training being turned on. So you could turn on Contra, and you can say I'm interested in that primary training. You can turn on these different capabilities, and some of these require a subscription, but what these would do is on various vulnerabilities, you'd be able to actually link out to a security training related course and learn more about that. Okay. Now let's actually change a few things. So I'm going to turn this off. Okay. So let's look at this file called the code owners. And this is a compliance feature that is quite important to kind of pay attention to and to know about. This is absolutely core if you have lots of developers sort of working together on various files, right? So let me quickly describe, well, what exactly is the code owner? So in the GitLab documentation, you can kind of find information about this. So a code owner's file is essentially a file that just sits within the root of your repository with no extension, and it specifies the users and shared groups responsible for specific files and directories in the repository. Okay, so you can put it in the root, in a docs, or in or sort of at a high level within the .gitlab directory, right? And within that, the format is always file name. So whatever file it is you're interested in having and specifying a code owner for, you'd specify who's the developer that manages it and who's the maintainer of that particular file. So that's the essential format. Okay, given that, I'm just going to jump back and we'll continue. So we're going to go into our repository. So I'm going to go to code repository. And we're going to open up the Web IDE. So I hope everybody at this point is familiar with opening up the Web IDE. So I just went to the root of my Tanuki Racing Security and Compliance Workshop project. Go open up the Web IDE. And I'm going to add it on the side here so that I can work on it. And I'm going to create a new file in the root. Sorry, I'm just moving my. Okay. And within that, I'm going to make sure I place in there this code, except I'm going to have my name for that username. So, okay. And then the other would be for Logan. So that's all you need to do there. It's going to give people 30 seconds. So this portion's your username. Make sure there's an @ before whatever your username is. And once again, if you're not sure what your username is, you can always click on the Tanuki on the, sorry, over your name here, and you'll be able to see what your username is. Okay, so now if you've added that in, we want to commit this to main. So I'm going to hit the source control extension. So this is the Explorer of files. I'm clicking over to the source control extension. I want to commit this code to main. Not a good practice, but generally you should use a feature branch if you can. So I'm going to say commit and push to main. Okay. And you want to make sure that you click commit to main, and then on the pop-up, you want to go back to the project. So I just want to go back to my project. So I'm going to close my IDE here, and just click on it, and I can see my code owners file. So what this does is, if you know, we now have a code owners file, and now we're going to check on the license compliance piece. Remember, we saw Nikita had added a license compliance for LGPL3. I had followed through. So if I have followed through, I should be able to kind of walk through step 5 and continue. So now we want to see these two things sort of working in action, right? So we'll go back and open up the IDE in the edit drop-down list. So I'm going to scroll up here, reopen that IDE. I'm going to paste it on the right side. Then I'm going to locate a file called tanukiracing.gemspec, right? So let's look at that. So tanukiracing.gemspec happens to be the very last file here. So I'm going to open that up and add the following line before line 22. So I'm going to just come over here. I'm going to copy that, find line 22, and I'm going to paste that there. Okay. Now, presumably, Sidekick has LGPL, could be what we're trying to trigger here. So I'm going to make sure that that is saved. We also want to manually replace the gemlock file contents to include all the changes that a bundle install with the Sidekick gem would require. So part of enabling this is to copy that, and I'm looking for the gemfile.log file. So here we go, gemfile.log, and I want to take all of that and replace it. So I just replaced the entire contents of this block, into that file. And I kind of save that. So I'm just going to scroll through here. So once added, I'm going to click the source control button and do a quick commit, and then click the down arrow. So I'm going to go back over to source control. I'm going to go down here, and I'm going to create a new branch and commit. So I'm just going to slow down here for a second, wait for people to catch up. So we're about to create a new branch and commit these two changes that I have made. Okay. So I've done that, and I'm going to ask it to create the new merge request, right? Okay. So if you look at that, I believe we have to uncheck that. Sorry. Let me actually do this. I'm just going to go back to my dual screen option. So I don't need this anymore. And I'm going to come here. Uncheck that and create the merge request. Okay, so let me, good thing I didn't delete it. So I'm just gonna uncheck that and create the merge request. And what you will notice is we have a preventative security policy that does not allow, this is a prior policy that was created. Here's my deny LGPL license rule kicking in. And finally, you can see here that the gem spec file also has a rule that has kicked in. So my merge is blocked because of the different policies that are being put into effect here. Okay, so let me return to my shared screens. I'm just going to refresh this so that we can look at that merge request. So once again, we have LGPL and code owners working together to block that out. So here you can see that if you wanted to change this, you can, the appropriate person has to either approve this change and allow it to move forward, or you have to be added to a code owners file to be able to actually complete that. But again, part of the problem is the fact that this particular license requires approval. And with that, we've sort of reached the end of this issue. You can now come to the very bottom and close this out. And I will now return to the slides to round us off. I want to talk a little bit about now how you actually get all this work that you've done over into your particular environment. Let me open up the actual files. Give me a second. By the way, you can only transfer when you're done. So be sure you don't try and perform the transfer actions until you are fully complete, right? So for those instructions, if you come back to your sort of instructions, area and come to your repository and you go to courses, there is a transfer project folder. And in there are all instructions for that particular transfer. Some things to be aware of is if you do not have Ultimate or a premium license, there are some of these capabilities that will not be available. The following steps are the steps you can take. You can choose to transfer either just the project, or you might choose to transfer the whole group. There are limitations. You should make sure you have no containers, otherwise that transfer will not happen. So make sure you follow each of the steps to make sure that that transfer is successful, and only when you've completed it. Okay, so these will be those instructions. So once again, those instructions live under the same Tanuki Racing project, under courses, transfer project, and there is a markdown file that you can read there. So with that, I'd like to kind of go back up here. Again, this is courses transfer project. To conclude, shifting left, when done well, you'll be able to scan your code on every commit, on every change. It'll be seamless to developers. They won't sort of see or feel as it happens. You're using a lot fewer tools. This is the power of a single platform to kind of guide and support the process of building software. With DevSecOps all being on the same page, everybody would be aligned, and you'd have all the information that you would need to supply to your auditors. So at this point, I kind of wanted to jump over into any kind of live QA. So please, if there are any outstanding questions for me or my team, please go ahead, unmute, and maybe you can take 2 or 3 questions.
So they won't be able to unmute, but if you just type your question in the chat or the QA section, I'll read it off for our team to answer. First question, is it possible to transfer to an on-prem server? So long answer is yes. Basically what you need to do is download the project as an export. Instructions are slightly different. If someone could grab exporting a project and importing from the docs and paste in the chat, that'd be nice. And then like once you've downloaded it, you would just import it to your on-prem server. So it's different than what's there, but it's still possible.
Thank you. Other questions?
I see there's another one, and Kyle, I know you're actively typing away. But how accurate is the license detecting in the Java world? Lots of artifacts in Maven have multiple licenses, missing licenses, etc.
I guess it's as accurate as the ability of the scanner to find those particular license files within the artifacts or within documentation that describes it. So, I mean, in general, I've seen it capture probably, more than 80% of what, most developers will scan, as long as we're talking about things that are being are following a standard. You should find a lot of these items. If you're concerned about these other aspects, then it may make sense to use a different kind of scanner that perhaps is looking more deeply at these libraries, or you have a prior sort of ingestion of an SBOM that would describe the particular known licenses that apply to some of these libraries.
Sweet. And I do know, like we have a full team that looks at these and is constantly updating them. So if there are new ones, rest assured they'll be covered pretty quickly. The next question we have, do you have a matrix that shows exactly which capabilities are available in CE versus paid tiers?
Yeah.
Yes, I'm almost sure it exists somewhere. I'm trying to remember.
Yeah, I'm trying to locate the link, James, so I'll put that as a response to this question.
Okay. Yeah. Thank you.
Can you also throw it in the chat, just so it's easier for others to find? Thank you.
Yeah, and if I remember correctly, there aren't many scanners that are included in the CE. I think you may only have, please don't quote me on this, but I think secret detection and maybe container scanning were the only two that
Yeah.
are in CE, and then the rest kind of
Yes.
in the rest.
So, and you can include, I think, the SAST. I talked about advanced SAST. Advanced SAST is not there in the community version, but then the regular SAST, like the normal SAST, that's there. You do not have the dynamic application security testing. DAST is not there in the free version. So, yeah, let me share the, yep.
Yeah. Thank you. Another question?
While we're waiting for another question, Jonathan did put a survey link in the chat, so it greatly helps us to get y'all's feedback. If you do just have 2 minutes, click the link in the chat and please fill out that form.
Yeah, let me make sure that I believe this is it too.
And then the feature comparison was also just sent to the chat. Give it a few more minutes for questions, and then we'll go ahead and wrap it up. Another question came in. For the SBOM report that is generated for licenses, would it be enough to include the license verbiage in our software documentation to be compliant with open source licenses, or do we need to comment them in the actual code file?
So these licenses tend to be pretty standard. So my sense would be having the precise name of the license and the version. You can normally triangulate back and figure out exactly what the verbiage of that license is. So I would think it's really just identifying the precise license and version that is key. That's my opinion.
Yeah, I agree. I think that besides that, it is dependent on which government agency you're possibly dealing with.
Correct. Correct. You might need to do additional work, but there are a couple of sites out there that, especially even Wikipedia, I believe, describes every single known license out there in excruciating detail, what it allows, what it doesn't allow. So that can be possibly, taken and put into a tabular format. All right. Thank you.
Any final questions? We have the experts here, so don't be afraid. And if not, please take the 2 minutes to fill out that survey. I'll post in the chat again the slides. You will get a copy of them via email. But if you want one right now, there they are. So thank you again, everyone, for attending today. We'll hang out a couple more minutes to answer any last minute questions. Hopefully you learned a thing or two. We will be back next year with a workshop every month. Important that you do fill out that workshop survey just so we can, provide the latest and greatest kind of subjects. We want to put out the information that's relevant, that you want to know, that you want to walk through. So take those 2 minutes. But thank you again for attending, Like I said, we'll be on a couple more minutes to answer any more questions.
We did have another question come in. The site profile can run on prod of a website, which I believe is reference to the on-demand scan.
Can it run on a what?
Prod of a website.
It can. It's generally not a good practice to run these kind of scans against a production site. If you think about what dynamically application security testing is doing, it might be testing actual code paths, which means it might have to submit data or that could go in, and this is not really what you want happening on a production system. My suggestion is, as most good software development processes go, you typically have a staging environment, and that's probably what you want to target for your DAST scans so that they are as much aligned to your production as possible. I recognize the risk that is there, which is what if there's an unknown difference between your staging and your production? Um, that has to be weighed with the possibility that your DAST scan could insert something you never expected or didn't want, and that's your production system.
Sweet. And besides that, I think that is all the questions.
Thank you all.
Awesome. Thank you again, everyone. You will get a copy of the deck and recording. So see you at the next one.
Thank you all.
Okay.
Thank you all.